All right. Hello, everyone. Welcome back to Comp 2150, Object Orientation. The first thing I want to show you is that video that I asked you to watch. The video that I gave you as homework that's 4 minutes long that everyone has watched now, right? Right? Yes? Good? Good? Yes? Yes? Okay, good. The video that I asked everybody to watch, it got posted to this website that I go to on the regular. It's called Hacker News. It's at news.ycombinator.com. And it's, I don't know, it's just like a link aggregator. There's a bunch of stuff on here that's kind of related to computing, and it's a little bit more like California-centric and venture capital stuff. And I kind of ignore those things. I'm more interested in just the computing and computer science stuff. But that video got posted, that Watt video got posted, and there was an excellent link that I saw on there that is a web page here that lists all of the different type coercions that can happen between different values in JavaScript. So that whole like bizarre situation where the empty string equals the number 0, these are all of the different situations or all the different ways that you can coerce between types in JavaScript. I put a link to this on the course web page. But you know, there's weird things like you can have a -0, and as you're all in 2280 right now, I'm sure you're familiar with this idea of a sign bit on a number, and you can have a -0 and a +0. -0 gets type coerced into a string that is like +0, string with the string that has 0 in it but no sign attached to it, which is kind of a weird thing. The null keyword here gets coerced into a number and it turns into 0, which is, yeah, kind of a weird thing. All these ones that are yellow are WTF. The array, the list that consists of not a number, turns into a string that is just not a number, but with no square brackets around it. And if you've watched that video, they abuse that to say, no, Batman. It's great. It's great. Please watch the video. Please do your homework and watch that video that I keep asking you to watch. OK. What I want to do today is spend a little bit of time continuing with A01 and JavaScript. And eventually what this is going to turn into is a discussion of some of the effects of shadowing that we saw in other languages. So remember, we've got variables that are attached to classes, instance variables in C++. In Java, we have methods that are attached to classes. And if they have the same type and the same name, they can be shadowed between superclass and subclass. And there's different kind of effects that can happen there. And we're going to take a look at that in JavaScript. I want us then to move on to looking at abstract classes and methods in JavaScript. This is something we've done in Java. This is something we've done in C++. So let's take a look at how this works in JavaScript. I want to talk about something that is sort of unique to the kind of language that JavaScript is. So we are spending a lot of time talking about getting behavior and data from a superclass by inheriting from that superclass with the extends relationship. But dynamic languages like JavaScript give us the ability to just add behavior to classes. And we've kind of seen that already by doing bizarre things like changing the superclass at runtime. But we can also do this in not a bizarre way and just add behavior to classes without having this is-a relationship using something called mix-ins. And this is sort of related to default methods on interfaces in Java. So we had this idea of we can put behavior in an interface as long as it doesn't interact with the state of the class. We can do that same sort of thing with JavaScript, but we are allowed to interact with the state of the class, and we can just inject things into a class. The last thing that I want to spend some time doing today is talking about assignment 4. Assignment 3 was due yesterday. Assignment 4 was up yesterday. We're getting real close to the end of the term, so we're kind of buckling in and getting on going. So today I want to change things a little bit. I don't want to just stand and type JavaScript the whole class, because it's a little bit more of like, we've seen the syntax already. We've seen this idea. I am going to write some JavaScript, but I want to spend more time just like thinking about it and kind of working through some problems together. So JavaScript has an inheritance. JavaScript has inheritance, and that's great. That's really, really excellent. And one of the things that we saw with inheritance in other programming languages like Java and C++ is that there are some unexpected side effects related to the names of types and the names of methods. That was this idea that we have a superclass and a subclass that have a same name of a property, and they can shadow each other. So I want to do a little quiz. Shadowing, just to remind you, to put us all on the same page, shadowing is this idea that we have a parent and child class, and a variable, this is specifically what we're thinking about right now as variables. Instance variables have the same name in the parent and the child class. And the way that inheritance works in JavaScript is we can have a parent class and a subclass. And when we have that extends relationship, we get the methods, we get all the methods inherited, but we don't really get variables, instance variables inherited, because they don't exist until we actually execute the constructor on that superclass. So with that, let's do a quiz. The first question has nothing to do with shadowing, by the way. That was my big lead-in, and then it's just anticlimactic. Oh no, Rob has joined the quiz. 2 more weeks. JavaScript, thumbs down, TypeScript. Okay, yeah. If you're looking at JavaScript stuff, you're going to find TypeScript. TypeScript is what's called a superset of JavaScript. It's the theory is kind of like C++ is supposed to be a superset of C, but it's not. But TypeScript is JavaScript, but it has types attached to it. So you can have types, and then it gets converted into JavaScript. All right, I'll give you 10 more seconds to join up, and then I'll start. OK. So the first question is not about shadowing. It's not about shadowing. OK, all right, OK. So this is that question that I left you with last time. And the question that I left you with is, just can we even do this? Can we have covariant types? Can we have contravariant types for return types and for method parameters specifically? This is a tiny code fragment, but it sets it up in the same kind of way that we would have with Java and C++. We can't have covariant return types here because we don't have return types. When we declare this method that's called method, imaginatively called method, we don't say that it returns anything. It actually implicitly returns something, and it implicitly returns undefined. In this case, we're saying, I would like to return new super and new sub, but the method itself, the declaration of the method itself, doesn't state a type at all, because there's no type in method signatures in JavaScript. Similarly, parameters here, remember, they're just like a suggestion. They're barely there. We are sometimes looking at the number of parameters that are passed to a function or a method to try and decide whether or not we should behave one way or another by inspecting that arguments array. But we don't have types. We don't have types on these parameters, so we kind of can't have covariant or contravariant methods, or types, return types, or parameter types. By definition, in JavaScript, when we have a superclass and a subclass like this, if we share the same name, we are replacing the whole thing. We're just overriding it. We are overriding it because of the name of the function itself. So we can't really have covariant or contravariant types. Okay. The next questions are going to be about shadowing. Watch the video, please. It is funny. It is very funny. Okay, good. In this example, we have main is creating an instance of a statically typed variable that is statically typed to shadow, and it's an instance of that class. So they're both the same in this case. And when we're printing out dot value on that type, it's going to print out what's in this class. We've never actually referred to this small shadow class at all, so shadow is what gets printed out. Oh, I fell right off the top there. Actually, it wasn't me, it was my bro that fell off the top. Okay. What? Okay. Shadowing in Java is when we've got a superclass and a subclass. Both of these classes, shadow and small shadow, have the same name variable called value. We are indeed creating an instance of small shadow here. But when we're referring to properties on a class, we're referring to the static type. The static type of this variable s is shadow, which is the superclass. So when we print this out, it's referring to the value that's in the superclass itself. Even though this is like dynamic class binding, we have a subclass as the instance. It's the static type that we're referring to when we're looking at this instance variable. Okay, great, excellent, really good, really good. Okay, one last point to make about this is that in Java, our class shadow, it has its own value variable. That instance variable is its own thing. Small shadow has its own variable that's called value. They are two completely separate things. Even though we're calling the constructor, the superconstructor in the subclass and saying it also says this.value equals something, it's referring to its own copy of that variable. The subclass refers to its own copy of that variable. So they're two different things. But good, excellent. Kurt, staying up there. We're switching to JavaScript now. Okay, good, 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 good. In our code sample here, it's kind of similar to the first Java example. We're not ever referring to small shadow here, so we would never have had that value set in any class because we're just creating a new instance of the superclass and then printing out its value. This is a tight race. Okay, good, good. I want to step through this just to make sure. I know you're all picking the right answer, but I want to step through this to make sure that we all understand what's actually happening here. We're creating an instance of this small shadow class, and we're calling the constructor. The constructor here on the first line, we are obligated to call the superconstructor if we are declaring our own constructor in a subclass. The constructor in the superclass starts executing, and at this point, the object that it is that we are creating will have this new attribute added to it that is called value. It didn't exist before. It's only now existing once we've executed this line that says this dot value equals shadow. Once that happens, we return back to our caller, so in the constructor of the subclass. And here we are just replacing the same thing. We don't have different variables in the superclass and the subclass. When the superclass's constructor executes, it's adding this property called value to the instance that we are constructing right now. It's not taking it from the class definition, it's just adding it to the current instance. When we get back down into the subclass, we're modifying that same variable. We're just changing that variable that we set previously. So when we print this out, we're getting small shadow there. Does that sound okay to everybody? Good. This is like, look at this. 5255 and 5253. This is really tight. Okay, okay. I am trying to trick you here a little bit. Let's step through this again, order of operations. We are constructing an instance of small shadow. So we call the constructor for that class. The constructor for small shadow starts executing, and the first line that we run is to call the superclass. The superclass creates this new attribute for the instance that we are currently creating. It adds a new thing to this instance of this class that's called value, and it gives it a value of shadow. We return back to the constructor of the subclass, and then we modify that exact same value. It's the same physical thing that we're changing here. When we leave the constructor, even though we have this hierarchical class relationship, there's still only one variable that's shared between both of those classes. We didn't inherit anything there from the superclass. It was just created when the constructor was called. So when we call obj.print here, yes, we are invoking this method. We're invoking the method that we inherited from the superclass. but this dot value, that variable is shared across both of those classes now. So it's going to print out whatever the last thing was executed that made the change to that variable. Okay? Okay? We're good? Good, 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 good. Franklin's bro is the highest climber. Good, 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 great. So again, I want to step through this. I want to step through it. We're creating an instance of this class shadow. We go to the constructor. We have a private variable. This is kind of private to the enclosing scope. It belongs to this class name now. It belongs to this class. We set the value of that private variable to shadow. We call the print method in the superclass. We refer to that value in the superclass. We never declared an instance, or we never tried to create an instance of small shadow, so we don't refer to that class at all. This is just like shuffling up and down here. Okay, this is the last question. Okay, okay, okay. The last one that we saw that looked like this, let's take away the private parts. Take away the private parts. Take away the private parts. Take away the number sign value. We're just having this dot, this dot. When we have a public instance variable in a class, it gets initialized by the constructor. It doesn't exist until the constructor is called. So adding that attribute to the class, adding that attribute to the instance of the class only happens when you execute the line that says this dot whatever equals something. Private variables in JavaScript, private instance variables in JavaScript are in the local scope, in the enclosing scope. Because this class has been declared, shadow, with its own private instance of this variable, it has its own private instance of this variable. It's not the same as the one that's declared in the subclass. In small shadow, we have a private variable that is coincidentally the same name, but because it's marked private, it is within that scope only. It's only within that scope. So when I create an instance of small shadow, I call the constructor here. We call the superconstructor, very first thing. In the superconstructor, in this enclosing scope for the class, we have a variable that's called value, and it's local to that class. It's local to that class. We set a value to shadow, and we return to the subclass. And in the subclass, we have a variable that is coincidentally named the same, but they are physically separate from each other. They're not the same. They're physically separate from each other because they are private, only because they are private. We set that one to small shadow, and when we print, we're calling the print method that we inherited from the superclass. And the superclass's inherited method is referring to that private value that we have in that enclosing scope of that method itself. Is that okay? Is that okay? Okay. The only way we can get shadowing with variables in JavaScript is with private variables. Public variables, because they are just physically the same thing across subclass, superclass, and subclass, we can't get shadowing. It's just the same physical thing. Private variables, they are different physical things that have different locations. They can be shadowed. We can have shadowing effects here. Methods also cannot be shadowed, because as soon as we have another method with the same name, it just replaces the existing methods with that name. Kind of anxious to see who's at the top here this time. TypeScript. 2 more weeks, yeah. Cart. Congratulations to Cart, to whoever Cart is. Congratulations to Cart. Hey. All right. Here's a summary. There's different behavior for public instance variables, private instance variables, and methods when we're talking about shadowing in JavaScript. With public instance variables, there's no shadowing. There is no shadowing effect because they are kind of like they only come into existence when constructors are invoked. They only come into existence when constructors are invoked, and they're modifying the same physical object. Private instance variables, we can have shadowing effects because they're local to the enclosing scope. They're only really visible in the class that has declared them as a private thing, which is kind of the same as what we saw in Java and C++. In methods, there's no shadowing. We just have a method that has a name, a function that has a name. Even if we put different numbers of arguments and parameters in different places, we're just getting the last one. It's always just the last one that's declared. If we override a method, we override the method. We can't have shadowing effects. This is effectively the same, though, as Java versus C++. We can't override a method in Java and not have it be the one that's in the subclass that gets invoked. This is only something that we could see in C++ when we didn't mark a method as virtual. Yeah, we can't shadow methods because we can't turn off polymorphism in JavaScript in the same way that we can't in Java. Whereas in C++, we were able to do that by doing things like not marking a method as virtual or having stack allocated instances of classes. All right, so let's switch topics here. I'm going to let you read that, and then I'm going to read it aloud to you. We've been talking a bunch about inheriting from classes in JavaScript. But one thing that we haven't talked about is checking to see what instance a class is of. We haven't bothered asking. We also haven't done things like casting between types. We haven't casted between a subtype and a supertype. JavaScript is a language where we've got an object. We have objects. JavaScript is a language where we don't really care that much about what type something is. The only thing that we really care about is, can I invoke this method on it right now? I don't care what type it is. I just want to know, does it have this method? Can I run this method? Can I run this function? Can I run this behavior? This is called duck typing. This is the actual name of this idea, duck typing. And it comes from this phrase, if it acts like a duck and quacks like a duck, then it must be a duck. That's just I don't know where that, I really don't know where that comes from. English idiom from somewhere, I don't know. But it's an idiom. It's something that says, if you have a thing that looks like it's a thing, then it must be that thing. The way that we test that in JavaScript is, we bring out our duck buddies and we say, hey, are you a duck? We don't really say that. We instead do things like, can I invoke this method at runtime. So I have those classes. I've got MegaDucky, and I've got this new class that I'm calling NotDucky. MegaDucky was that type that we created. We had RubberDucky. We had RubberDucky. And another one. And then we had MegaDucky, which had like a capacity for smaller duckies. And then we had LightUpDucky. And I'm really depressed that I didn't get to do this joke last class, because that's what this is all about. We've got those different types. And when we were setting that up, we had this relationship between RubberDucky and MegaDucky. MegaDucky was a subclass of RubberDucky. Here, I've got this new class that's called NotDucky. It has no hierarchical relationship to ducks at all. That my duck classes had this print method. And when I declare an instance of this MegaDucky type and I assign it to this variable that's called Ducky, it makes sense that I should be able to call a method that's on that class. JavaScript, though, is this dynamically typed language. If I reassign a value to a variable that is of a different type, there's no problem here. I can just do this. I'm not constrained to the static type that's attached to the variable at the beginning when it's declared. We can still just run this method because it exists on this object at the time that I'm trying to call it. When we were doing this sort of thing in Java, we had to constrain ourselves. We can only assign types that are subtypes of this one type that we have on the right side. That's subtypes of the static type for this variable. And in JavaScript, we can just blindly change it to something else entirely. We've seen this type of operator a few times. I've been typing this into my console a bunch. But there's also this other thing called instance of. Instance of does what you think it does. Instance of asks the question, is this assignable from this type? So if I have a supertype and a subtype, are they related to each other, true or false? Type of tells us what type an object has at any given point. If I have a number in a variable and I call type of, it will give me number back. If I have a big integer, it will give me big integer. If I have string, it will give me string. If I have an object, it will give me object. And user-defined classes in JavaScript are always of type object. It doesn't matter what the class is that you have in this variable, it's always going to be object when you ask what type this thing is. Instance of gives us the ability to ask questions about the hierarchical relationship of whatever an instance is at runtime and another type. It works in exactly the same way as it does in Java. You have a supertype, you have a subtype. Is this instance of this supertype or subtype or whatever, and it tells us true or false. But why do we care? Why do we care? The only times that we ever cared to ask, is this an instance of this type, is to do things like, I want to be able to change the type of this thing to another type so that I can call more specific methods on it. I'm accepting as input some supertype. I have subclasses of that. I'm asking, is it an instance of this subclass so that I can cast it to that subclass and then call methods that are on that subclass itself. In JavaScript, I don't need to cast to call a method. I just call the method. I just try calling the method, and it either works or it doesn't. So the question with JavaScript is less, is it an instance of this class? Can I assign it? Like, can I have this hierarchical relationship between classes? It's less of that and a lot more of, can I call this method? Does this thing, does this object that I have right now have a behavior that I want to be able to invoke on it? In Java, our conditional statement here would basically be if ducky instance of RubberDucky. In JavaScript, I don't care what the class is. What I really want to know is, does this object that's called ducky have an attribute that's called print? So when I say ducky.print and I don't put parenthesis after this, so I'm not trying to invoke it, I'm just asking, tell me what this property is. Passing this to type of is then going to tell us what type that thing is. If it doesn't exist, it will be undefined. The type of something that doesn't exist on an object is undefined. But if it is a function, if it's something that we can invoke, then invoke it. On the next line within that conditional statement, run it. Just run it. I don't care if it's a type of one kind of class or another. I just want to know, can I run this method or not? In JavaScript, it's pretty uncommon to ask instance of. You can, but it's pretty uncommon to ask instance of, and a lot more likely that you're just going to ask, can I run this method on something? All right. Does that sound okay to everybody? Duck typing, ducks, ducks, ducks. You should just buy hundreds of ducks and put them on the desks in the exam hall. Wonder if I could get them in time. Something to think about. I need to go to the duck superstore and see if I can find them. But only for our section, not the other section. Yeah. I don't want to spend $200, but I would spend like $50. Anyway, JavaScript is a language that pretty clearly has classes and inheritance. Even though we're not often going to be thinking that way, it's convenient to have this relationship between class types so that we can inherit methods and behavior, but we're not often going to be thinking that way. JavaScript does have classes and inheritance, and that's great. That's really good. It's something that we're comfortable with. It's something that we've seen a lot in Java in the languages that we're used to. JavaScript does not have abstract classes. It doesn't have abstract classes. C++ gives you the ability to create and declare a class as abstract by marking a method in it as a pure virtual method. JavaScript just doesn't have abstract classes. End of discussion. Let's move on. It doesn't have abstract classes. There are no abstract classes in JavaScript. There are no abstract classes in JavaScript. JavaScript doesn't have a language keyword to make a class abstract. C++ doesn't have a language keyword to make a class abstract. C++ gives us the ability to mark a class as abstract by having a pure virtual method on a class. This is a link, this first thing here, this is a link to the lexical grammar for JavaScript. The lexical grammar itself is not really that important. What's really important to me right now is the list of keywords that are in this document. I'm going to scroll down. These are words that you've seen before, that you are familiar with. These are words that are reserved in JavaScript because they have specific meanings. These are all words you recognize, I think. There are words that are reserved when we turn strict mode on. So let is not a reserved keyword until we turn strict mode on. That means that we could have a variable that's called let, which is kind of weird, but you could do it, I guess, if you wanted to. There are future reserved words. The people who make ECMA scripts or JavaScript are basically saying, hey, we think we're probably going to do something like this in the future, so don't use this keyword in your code because it might be reserved later. So they're kind of saying, in advance, don't use the word enum to declare as a variable name because we might actually add enums to this language at some point in the future. We might add things like implements and interface and package and private and protected and public. Hey, those words look really familiar. They look really, really familiar. Future reserved words in older standards. And the first one there is abstract. That implies that this was at some time maybe planned to be a feature of JavaScript, but it doesn't do what you think it does. When you use this keyword in your editor, it might highlight it and say, hey, this is a reserved keyword, but it doesn't do anything. It doesn't actually do anything. It's not reserved anymore by the current version of ECMA script. JavaScript doesn't have a language keyword to make a class abstract. So we can't declare a class as an abstract class. My question here is, when we could mark a class as abstract in Java, when we could declare it sort of as abstract in C++ with a pure virtual method, what were we actually trying to accomplish by doing that? Please answer this question. What were we actually trying to accomplish? What do we even want from having the ability to make a class abstract? Oh, I got to press enter to show answers. Just because, yeah, okay. To cause pain to students, okay. To force behavior on subclasses, yes. That was one reason why we wanted this. We wanted to be able to say, I've got a method. It's an abstract method. If you extend me, you must implement this class. You do not have a choice. If you don't, I will refuse to compile your code. To not have instances of them, a superclass that we can't make instances of, to prevent instances of a class. We were trying to accomplish not being able to call the constructor. We could have constructors in an abstract superclass, but we could not call the constructor anywhere except from subclasses. We could call super in a subclass, but we couldn't actually call it from outside of that. Do I have the high ground? I don't know what that means. And I actually really like this. I want to be this, but I don't want to be this. Yeah, I'm pretty sure that's Rob. Yeah, that's definitely Rob. If you don't know Rob yet, you will know Rob soon. I don't know. You'll know Rob eventually. You'll know Rob eventually. Rob has humor like this. I want to be this, but I don't want to be this. Yeah. An interface for behavior and variables. So we can't create instances of it. It's an interface. It's specifying behavior. And it's also giving us the ability to inherit behavior. And it's giving us the ability to inherit some data. It's giving us the ability to do that. OK, that's excellent. Thank you. I want to be able to not create an instance of this class. That was one of the things I wanted to be able to do. I wanted to refuse to allow you to create instances of this class. I want to be able to specify behavior. You must implement these methods, or I'm going to not compile your code. I want to be able to provide some inheritable state and behavior. I want to have some variables, and I want to have some methods that you can inherit by creating private or public instance variables and by defining methods within the class itself, within the abstract class itself. JavaScript does not have a keyword to mark your class as abstract. There's no way for you to say at compile time, because there is no compile time, at runtime, you should not be able to create instances of this class, or if a class extends this one, that you shouldn't proceed with reading it because it doesn't implement a method. There's no way we can do that, but we can simulate the idea of abstract classes at runtime. If you try to create an instance of this class, we can reject your creation. If you try to call an abstract method and it has not been overridden by a subclass, we can reject that call. We can just say, no, I'm not going to answer this call because it has not been implemented by a subclass. We can prevent instantiation of an object by throwing an error in the constructor if the constructor is called directly. Within a method call, we have access to this variable that's called this. Good, that's great. We've always had access to this. We can ask questions like, if this has a property that's called constructor. A constructor in JavaScript is just a method that's called constructor. That's all it is. It's not a special thing. It's not really a special thing in the same way that a constructor in Java and C++ was. The method constructor is just a method that happens to be named constructor. That's it. And if it's just a method that happens to be named constructor, then this, as an object, has that as a property. And I can ask questions about the constructor, like, please tell me what your name is. What's the name of the constructor? And in this case, what the name of the constructor is going to return is the name of the class that is actually invoking the method or is having the method invoked on it. I want to switch over to VS Code, and I want to start typing this in and kind of slowly going through this example just to make sure that we're seeing what's going on here. So I'm going to pop this open, and I'm going to open up this file that I've called abstract.js, and I'm going to start typing some of this in. I want to see this happening. I want to see this happening. So in this file, I'm going to start making a new class that's called abstract. And within abstract, I'm going to create a constructor. And then I want to ask the question, is the name of this constructor the name of the class? I'm actually just going to print out what the name of the constructor is. That's the first thing I'm going to do. I'm going to say console.log this.constructor.name. Constructor is a method. It's got a name. And I'm going to create an instance of this class. Put parentheses on it so we can feel warm and cozy on the inside. And I'm going to run this code. I'll run it on Node.js. And it prints out abstract, the name of the class that's enclosing this thing. I'm going to print out I'm going to add a new class to this. I'm going to call it implementation. And it extends abstract. So we've got that hierarchical relationship. Is this big enough at the back, by the way? Is that OK? Good, thank you. This implements, or this extends abstract. I'm going to create a constructor in this. And I'm going to write in here, console.log this.constructor.name. But the first thing that we have to do is call super. We must call super. That's the first thing we have to do in a class that extends another class where we're explicitly defining our own constructor. I'm going to put console.log in subclass. And I'm going to put like equal sign, equal sign, equal sign, equal sign to make sure that we can see this correctly. And I'm just going to print that out twice. Just clearly delineate where we are at a certain point in execution here. And I'm going to create a new instance of implementation now. This is going to start executing in this constructor. It will immediately call the superclass, and we'll see what constructor.name is when we're invoking this via a subclass as opposed to invoking it directly. So I'm going to click run. And now the name of the constructor is implementation. The difference here is In the first case, I am invoking it directly on the class name itself. So when I say let obj is equal to new abstract, the name of the constructor is what I called. The name of the constructor is what I called. So I'm calling this constructor on this class abstract. I wonder if I can do this. Now, I'm going off into uncharted territory here. I don't know if I can do this. It didn't print anything out. It didn't print anything out. Oh. It still doesn't print anything out. I can't do that. I went off into uncharted territory and I regret it immediately. When I call new abstract and I put parenthesis after it, I am calling a method. I'm calling a method, and the method happens to be the constructor for that class. When I do the same thing here, and I'm calling new implementation, I'm calling a method, and the method that I'm calling happens to be the constructor for this class, which is implementation. So what I want to forbid in this abstract superclass is I do not want you to be able to invoke this constructor directly. The way that I'm going to accomplish that is by saying if this.constructor.name is equal to, and I'm going to use triple equal signs. I don't want any type coercion to happen here. If it's equal to abstract, which is the name of the enclosing class. So if I call this my abstract, I'd have to make sure that I'm testing this against my abstract. I have to use the same name as the enclosing class. If this is true, then I want to throw new error. Thank you again at the back for correcting me from exception last time. Throw new error. You cannot create instances of this class directly. And I'll put a semicolon there. And what I'm going to do is run this. And we get an exception. That kind of makes sense. I literally just wrote the words throw new exception. We're getting an exception here. Abstract is not defined. Right, because I changed the name of it. Okay, we're still getting an exception, but this time it's for the reason that I wanted it to be an exception. You cannot create an instance of this class directly. I'm going to do this. I'm going to say let obj equals undefined, and then I'm going to say try. So we've used try catch blocks in Java to do stuff. Try and catch behave kind of the same way in JavaScript. I'm going to catch, and what I'm going to say here is console.log. I got to catch an exception. Exception. I'm going to catch an exception here. I've got to close the curly brace. That's what I'm telling me. That's what it's telling me. Got an exception creating instance of my abstract, which is what I expected to get. But when I call this new implementation, the subclasses constructor, it's going to work. Because the name of the constructor, when I run that, that constructor is not equal to the name of the class that I'm invoking it on. So we can accomplish don't call this constructor directly. We can pass things to our superconstructor still in the same way that we could in Java by asking questions about arguments. Use arguments if you want to get arguments passed to you. So we could do something like, I want to have a private value, and I can say if arguments dot length is equal to 1, this dot value is equal to arguments at 0. So if I want to pass things to my superclass, I can do that. Pass this string from subclass. This is good. We're kind of forbidding the creation of an instance of that class, but we can't do it at compile time. There's no compile time in JavaScript, but it's not failing when I hit the run button. The only time it actually fails is when it tries to create an instance of that class. So I can't forbid this from happening at runtime. This is happening only when we are creating an instance of the class itself. Abstract methods, they're kind of the same thing. The only way that I can make an abstract method in JavaScript is to have a method that just throws. You can't call this method because it's abstract. So let's do this. I'm going to add an abstract method here. I'm going to put in my abstract superclass here, abstract method. And all it does is throw new error. Must override. You must override this method. And if I try to call this, so I've got abstract method, throw new error. If I try to call this on implementation now, I'm going to wrap this in try catch again. Now I'll just call it obj.abstract method. If I run this, it's going to be able to create that instance, but I can't call it because it is throwing an exception. It's throwing an error. As soon as I try to run that method, you must override it. Prevents us from running it at runtime. So in my subclass then, I have to say abstract method. And I'll say console.log implemented abstract method. OK, and if I run this now, when I call that, it's going to be in the subclass. I've overridden that method from the subclass. So JavaScript doesn't really prevent us from having classes that inherit from what we want to be an abstract class at compile time, because there is no compile time. All we can really do is simulate that behavior at runtime by raising exceptions when you try to do something in a piece of code. I'm not going to do this. I'm not going to type this in, but you can inherit state and behavior from an abstract superclass in the same way that you would expect to in Java or C++. Keeping in mind that private variables, private instance variables here, and we're back to that shadowing discussion earlier. This is actually in that enclosing scope. So you don't have .private var in your subclass. And if you have a public variable that you're just adding to this class at runtime, you have access to that, but it's the same physical thing that's in the superclass. So you're using the same thing. All right. So JavaScript feels like it's half-baked all the time. Speaking of baking, let's talk about mixing stuff in. I like to make cookies. I like to make chocolate chip cookies at home, and I make pancakes a lot on the weekend in the morning. And oh, my daughter's adorable. She loves to help me. She loves to help me out. And I've figured it out. Like, it's taken months for me to get this like worked out so that she can actually help me. But she usually helps and then leaves like halfway through every time. Objects in JavaScript, instances of classes, objects that you create at compile time by just hard coding an object. Objects are all instance of object. They're all object. When you ask what type this thing is, it's all object. An object, remember, in JavaScript is just a dictionary. It's just keys and values. That's all an object is in JavaScript. It's a data structure. It's a straightforward data structure where we've got keys and values. But the values can be functions. The values can be behavior that gets invoked when we try to invoke it. In JavaScript, we can take advantage of this by applying an idea that's called mixing in behavior, adding mix-ins to the language. Mix-in, M-I-X-I-N, is a common word that you'll see in other languages that have this ability. We can declare a class that has no behavior in it. So this is contrived. There's nothing in this class right now. And then we can create this variable that I'm calling my mixin, but it's just a variable. It's just another object. It's just something that I've given this name my mixin. And what I have added to my mixin is behavior. This is a shorthand way of saying brand new print colon, not equals, but colon, function, and then stuff. So before, we added behavior to an object by putting a function as a value. This is kind of a shorthand way of doing that. We can add this behavior to an existing class by changing the prototype of that class. And remember, this is something that we abused last time to change the superclass of something at runtime. This is something we abused before to add behavior to a class that exists already or modify existing behavior. This method object.assign will take a target. My class.prototype itself is a dictionary. It's just another object. It's another dictionary. And it will take from the source and it will just go through all the keys and merge them into that object. So this object.assign is not replacing my class.prototype with my mixin, but it's taking everything that's in my mixin and it's merging it with this object. It's merging it with this dictionary. So all keys get copied over to this object. When I create an instance of this class now, even though this class definition, the class declaration, doesn't have this method, I can invoke this method because I have added it after that class has been created. This is something that we can kind of do instead of having things like multiple interfaces. If I want to have a printable interface, I can have a print mixin, and I can just mix it into different classes. I don't have to have this interface behavior to do that. This is really similar to that idea of default methods in Java interfaces. So we have this way that we can add some behavior to an interface and then mix it into the class by having it implement that interface, and it gets that behavior for free. This is kind of approximately the same thing. Okay. With that, I'd like to take a look at assignment 4 in the last few minutes of class. We've got about 10 minutes left, which is, I think, perfect for what I want to be able to do. We posted assignment 4 yesterday. It is due on the last day of classes on April 12th. This assignment is, I don't know, I think it's kind of a cool assignment. This kind of comes from my background. Olivier, the other instructor, the other prof for the other section, he is also from the same background that I am. We are both bioinformatics people. So we both deal with like biology and life sciences data and then take what we're doing in classes like this and apply it. This assignment is kind of working with some of the stuff that we do. So in bioinformatics and in biology and in microbiology, we really frequently want to be able to show the relationship between organisms. Organisms being like actual animals and people, or microorganisms like bacteria. So when I was working on this stuff, it was mostly bacteria. Olivier's working on this stuff. It's kind of higher level stuff. The way that we represent, the way that we communicate to biologists how much things are related to each other is in the form of this structure that's called a phylogenetic tree. This that's demonstrated right here is a phylogenetic network, but the primary, the original form of this was a phylogenetic tree, which is a proper tree. We don't have nodes in it that have multiple parents. But phylogenetic trees don't really accurately represent like reality. They don't accurately represent reality. When you've got bugs like listeria, for example, listeriosis is a kind of bacteria that can infect your guts. Your tummy right now has lots of listeria in it. It's got lots, but it's not the bad kind of listeria. I'm not looking at any specific person. Everybody in this room has listeria in their tummy. It's not the bad kind, but bacteria like listeria has the ability to do, I'm sorry, it's not listeria, it's E. coli. That's the kind that I'm talking about. I'm glad none of you are biologists and correcting me right now. I'm talking about E. coli. E. coli is a kind of bacteria that has the ability to, when in the neighborhood of other E. coli bacteria, just exchange genes. They can just be like, hey, here, have some stuff. Our own cells, we are, oh gosh, this is taking me back too far. We are eukaryotic organisms. We are eukaryotic organisms, multicellular eukaryotic organisms. It might be prokaryotes, I forget. We have mitochondria in our cells. Mitochondria are like ancient viruses. They're ancient viruses that just kind of got mixed into us. And at some point, our ancient ancestors just gained this thing. We just got this thing in our cells. In some realities, like in higher organisms, we have relationships between animals. So a mule is an animal where it's like parented by a horse and a donkey. This is two kind of different lineages that are merging into one. And this is where phylogenetic networks come from. We're showing a relationship where you might have multiple parents within a single node. The assignment that you have for assignment 4 with JavaScript is to read in a format that's called NUIC. NUIC is a text-based format that represents trees and networks. And your job is to recreate in memory the tree structure for that input, and then print as output trees to the terminal in JavaScript. The NUIC format was extended because it doesn't normally have the ability to represent phylogenetic networks. It just has the ability to represent phylogenetic trees. It was extended to support networks by adding support effectively for variables. It's got variables in it now. So we have this initial statement here. This is the initial tree structure that we've got. And N, X, and Y here are what turn into this phylogenetic network. So those three variables eventually get turned into this structure. In this first one, we've got N, and it's got these two X's. The two X's here kind of turn into one. It's kind of a way to say that there are two nodes that draw from this specific node. As you're building this, you would replace X with this expression. As you're building this, you would replace the Y's in here with this expression to get what you're trying to get ultimately. Parsing this is, it's a stack. It's a stack, and I'm going to scroll down here really far. Olivier has made this really excellent diagram. I really, really like this diagram that kind of shows how you would go about parsing this. So this is one single line that represents an entire tree, but you can parse this line and turn it into a tree-like structure with nodes by kind of reading and counting the number of parentheses that you're seeing. And as you're reading and counting the number of parentheses that you're seeing, you've got 4 here. This is the root of the tree. This comma indicates that everything that's on either side of it are the 2 subtrees that are below the root. And the way that you can figure out where the subtrees are is by counting the number of parentheses that are between the enclosing parentheses here. So these blue ones, I really apologize if you're colorblind, but the blue ones on the outside, those are the enclosing parentheses. This is the entire tree that's below the root. The comma there is saying these are the 2 subtrees that are below that root. And you can figure that out by counting the number of opening and closing parentheses to figure out which comma is of those 2 subtrees. The other thing that we're looking for you to do here is to find out a structure that's called a cherry. A cherry in the network is describing what it looks like when you've got this relationship between, I'm going to scroll back all the way up to the phylogenetic network that we've got here. So nodes, leaf nodes D and F are a kind of cherry because they're related sort of through this hybridization node, that Y node in the middle. The structure that we're getting you to print out here, this is kind of like top down, the way that we're showing it in this diagram. The way that we're actually looking for you to print it, though, when you print it out, is on its sides like this. So this is a textual representation here of that tree structure. You can do this by doing an in-order recursive traversal of the tree. Oh gosh, nobody ever wants to hear the word recursion again, but here it is. It's the best way to do this, is to do an in-order traversal of this tree. When you find a node that repeats itself, because you're going to have the same representation of subtrees multiple times here, when you find a node that repeats itself, you just have to print it out once. So you're going to have this node that's got two parents in it. You've got this node that has two parents in it. You only have to print that tree once. In order traversal, just in case you forget, we've got this idea of pre-order, post-order, and in-order traversal of recursion when you're going through a tree structure. In-order traversal is that you go to subtree, you visit the node, and then you go to other subtree. And then your base case is when you're at the bottom, you're at the leaf nodes. We want to get you to do like inverted in-order traversal, so go right first instead of left, but that's basically it. Go right first instead of left to get the diagrams that we're showing here. Post-order is you visit the node last, you do left and then right and then visit, and then pre-order is visit, left, and then right. The assessment here is that we're looking for you to build a data structure. We want you to have something called an abstract node class. It's highlighted because it must be an abstract class. It's not really required in the language itself, but we are insisting that you make this an abstract class. We don't want you to be able to create instances of this class. We want you to have a sensible hierarchy of nodes. Each of the nodes that are in this tree are of different types. There are different ways to represent it. You've got a root node, you have nodes in the middle that can have multiple parents, and then you've got leaf nodes at the bottom, and then internal nodes as other structure. The assessment is kind of approximately the same as what we've been seeing in our other assignments. So we've got programming standards, we've got output correctness. We're looking to assess you on the output. The sample input, so the tree that you see at the top, there's sample input that's attached to this assignment on the course webpage. The learning outcomes that we're assessing you here on are kind of similar to the first assignment in that we're looking for you to build a hierarchical structure of classes, but we're asking you to do it in JavaScript now instead of in Java or C++. We are assessing you on your ability to create tree types, so implement an abstract data type in JavaScript. And we are assessing you on your ability to do recursive traversal of the tree. You can do iterative traversal. You will get some points for that, but I guarantee you that it will be harder than just doing recursion. I know recursion is scary. Believe me, it took me a long time to get recursion. Without a shred of embarrassment, I will say that I never fully understood recursion until I was taking third-year programming languages courses. I just didn't get it. It's kind of scary to hear, but it is the easiest way to do this. It really is the easiest way to do this. All right, I will give you some time for questions on the assignment next week in class. But at this point, you should be able to create simple class hierarchies in JavaScript. You should be able to use duck typing. So no instance of, just ask, can I invoke this method on an object? You should be able to describe shadowing behavior in JavaScript. You should be able to simulate abstract classes and methods in JavaScript. You should be able to use mix-ins to add behavior to a class in JavaScript. That's it. Thank you all for coming out, and I will see you next week. Bye.